Hi, I'm Ms. Fung. Let's do relations, domain, and range. An ordered pair is like x and y, like a coordinate. A relation is a set of ordered pairs, so a bunch of these. So a relation is like the relationship between x and y. Example 1, let's say we have this set of ordered pairs. So we have 1, 1, 1, 2, 3, 4, 5, 6. And we can look at this as the domain of S is all the x values. So the 1, 1, 3, and 5. That should be a round bracket, sorry about that. So here we have 1, 3, and 5, and we don't write 1 twice. And the range is all the y values, so the 1, the 2, the 4, and the 6. We could also write the relation with a rule. So remember, we read this squiggly bracket as the set of x and y, where y equals x plus 1. And x is an element of 1, 2, 3, 4. So let me recap this from last lesson. So the squiggly bracket reads the set of x and y, and the double dot you read where y equals x plus 1 and x is an element of 1, 2, 3, 4. So we can write these out. And this is our domain. So x is allowed to be the following. So whatever you see after the comma, it's usually the domain, what we allow the x to be. So the relation is 1, when x is 1, y is 2. When x is 2, 2 plus 1 is 3. When x is 3, 3 plus 1 is 4. When x is 4, 4 plus 1 is 5. So that is the relation. So that's a rule, that's a relation. Both of them describe the same thing. So the domain of x is the set x, so 1, 2, 3, and 4. And the range is the set y, 2, 3, 4, and 5. Let's represent relations. We can represent it, we can map it. This is our 1, 1, 3, 5 to 1, 2, 4, 6. So this is the example before. We can map it and we can see that the 1 goes to 1, but also goes to 2. And the 3 goes to 4, and the 5 goes to 6. And we can map the other rule we did before, y equals x plus 1, and we notice that there is a more of a pattern over there. Now, why do we map these? You'll see it in the next bit. So here we have two more rules. We can map it, we can sketch it on a graph. So y equals x plus 1, it's a linear graph, you know that, and x is all real numbers, so it's like we've done like a lot of times. And here we have the same equation, but here the domain is only 1, 2, 3, 4. So it looks linear, but we only have 1, 2, 3, 4 as our available x's. So it's going to look like the same shape, but only just the coordinates. So notice the difference between when x is all real numbers and when x is only 1, 2, 3, and 4. Example 3, sketch the following graphs and state the domain and range. So when we sketch that, we will get all these dots, and the domain will be, we can look at the x values, but let's practice looking at it from the graph. So the smallest x value is -1, then we have 2, and then we have 3. And for the range, let's go from smallest, so down here, -2, and then we have 3, and then we have 4. Let's try another one, y equals 2x minus 1, where x is in between -2 and 1. So -2 is here, and 1 is here. So x is only allowed to be between -2 and 1. Not that way, and not that way. So the domain is between the x values of -2 to 1. And the range is, let's have a look, so -5 all the way to 1. And because these are inclusive, then our range is also going to be inclusive. Or because these are square brackets, they're going to be square brackets too. We can also write it in that set notation of the set of x, where x is between -2 and 1. And likewise, we can do that for the range. There's no right or wrong way to demonstrate that. They are saying or giving us the same information. Let's do one more example. This is a circle, x squared plus y squared is 4, where the radius is 2, and x is an element between -2 and 2, so between -2 and 2, so we have the whole circle. And in here we have the domain -2 to 2, and the range to also be -2 to 2. example 6, what happens in, you have y equals x plus 1, where x is greater or equal to 0. So now we start at 0 and we shoot all the way up. So our domain this time is, let's look at the x value, 0, and it keeps going on and on and on and on and on. So between 0 and positive infinity, or all positive real numbers including 0. So you can write it as either way. And the range, we have the smallest y value is 1, and it keeps going on and on and on and on forever. So between 1 and positive infinity. And because we are including the 0 at that point there, then the y coordinate for that point is also inclusive. One more, thanks for being so patient. Here we have minus x minus 3 squared plus 1. We know that's a parabola that is negative. Move to the right by 3 and up by 1. And we want x to be all real numbers. Now the turning point is 3 and 1. So let's sketch that. Oh, and the range can be figured out by looking at the graph. Sorry about popping that up first. So here we have x is all real numbers, so we want the whole graph. And we can see that the range, or the y value, the biggest y value is here, 1, and it goes on to negative infinity. Really, you should look at the bottom first. So negative infinity all the way, max number is 1. So negative infinity, remember infinities are always round bracket, all the way to 1, and it's inclusive. Example 8. The set of x and y, where y equals x squared minus 2x plus 3, and x is an element of R, or everything. So here we have to complete the square to see what our parabola looks like. If you've forgotten how to complete the square, please go and revise. You'll need to use this a lot. There's a link in the video in the comments below. So here we have minus 2. So to complete the square, we divide by 2. So we'll have x minus 1 squared. And 1 squared is, we're adding 1 to complete the square. So whatever we add, we have to subtract. So minus 1 plus the 3 gives me plus 2. So we know the turning point is at 1 and 2. 1 and 2. And we can look at our range and we can see the smallest value is 2, inclusive because we're touching it, all the way to positive infinity. Okay, one last example. The set of xy, where y equals x squared minus 1, and x is between negative 2 and 1 inclusive. That's the domain. So we have to sketch between that. So here we have a parabola that's been translated 1 down, and we have to stop between negative 2 and 1. So negative 2 to 1. And we can calculate using substitution what the y values are. So if I was to put negative 2 into there, negative 2 squared is 4, 4 minus 1 is 3. And if we put the 1 in there, 1 squared is 1 minus 1 is 0. See, it's over there. And we know that the turning point is 0 and negative 1 over there. Now, because this is not including the negative 2, we have an empty or a white circle. And because that is inclusive of 1, we have a full or a dark circle. We have to put the circles in so that we can explain the range. So the range is the smallest y value, which is here, minus 1, and it's inclusive. And it goes all the way to 3, but exclusive. So negative 1 inclusive, square bracket, 3 exclusive, round bracket. Okay, that's it from me today. I'll see you next time. Bye.